Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 5, Lesson 16, which is constructing nets. For lessons 15, 16, and a couple beyond this, we're talking about nets. And you will recall in the last lesson, a net is a two-dimensional figure, which may look something like this, where if you actually could cut along all these different lines, not cut, but fold, and then glue them together, you would have a three-dimensional figure, such as a cube. Now, one of the things that's hard about talking about nets in a video is that they're very visual and they're very much hands-on. So these videos will be fairly short, and I'll just show you a few examples of the kind of things we're looking at. But I think a lot of this will come to you even more as we talk about it in class and as you get hands-on and work with your groups. So today we're going to actually look at constructing nets, putting nets together. So let's take a look at an example here. Okay, this is not the best artwork, but let's say this is a pretty good rectangle as a three-dimensional figure. And I'm going to put some units on there. It could be centimeters, feet, inches, doesn't matter right now. But we're going to call this 8, we're going to call this 5, and we're going to call this line back here 3. Now, could you create a net for this solid? If you can imagine that this is essentially 6 sides. We have a front, we have a side, we have a side over here, we have a top, we have a bottom, and we have a back. 6 sides, and they're each going to be made of rectangles. So we can look at first the front rectangle, which I will draw over here, which we know this is going to be 8, right, because of that, which means this top side is also going to be 8. The sides will both be 5, right, because these sides here would be 5. So if you take the front here, you have that, and that is the front and the back of the box, so to speak. If we were to look at this side, these two sides here, we have something that looks kind of like this. We can see that we have 5 here, which means this other side would be 5, right? They would be equivalent. And then this portion here, it would be 3, meaning that would be 3. Okay. Now we have the top and bottom, which this is 8, meaning this is also 8. And then going back, since this is 3 here, this is 3, and this would be 3 as well. So I'm going to circle these just to give them make it easier to tell them apart. So we have these 3 parts, and you know there'd be 2 of each of these, right? So the top would also have a bottom, the front would also have a back, the left side would also have a right side. If you could put those together, taking these components over here and put them back together, you might have something that looks like this. And I'm going to label inside. As you see, here's a side here. This would be 8 and 8, 3 and 3. There's another flap, which would be 5, 5, 3 and 3. The same flap would be over here. 5 and 5, 3 and 3. Have this flap here, which is again 8 and 8, 3 and 3. And then you have that other big chunk, which is 8 and 8, 5 and 5, because this and this are going to be the same. So it's basically taking what we've already been doing, which is looking at these nets, but if you know the sides and how big they are, you can really label it. Now that looks very complicated, but it's just a matter of labeling 1 piece, 2 piece, 3 piece, 4 pieces, 5 and 6 pieces. It's just a matter of labeling them and then putting them together in a way that would fold and create our three-dimensional shape. Now, one of the things we can do with this information is we can actually find the area of each part of these to find the area of the total net. So if we're looking at length times width, I'll go one section at a time. Here we have 8 times 3. Here we have 5 times 8. Here we have 3 times 5, 8 times 3, 8 times 5, and 5 times 3. So what we end up with then is 24, 15, 24, 40, 15, and 40. And if we take these 6 numbers and add them together, we're going to end up with the total area of this shape. So 40 and 40 is 80, plus 15 and 15, which is 30, is 110, plus 24 and 24 is 48, so you end up with 158 units. Well, we don't know what the units are at this point. So we will talk about surface area soon enough. I'm going to stop there. I know this is a very quick video, but I think, again, the better thing to do is actually put in the work on these kind of problems with the surface, with the net, so we can break into different, the cubes and the different shapes, three-dimensional shapes that we can break into different nets, and then we can break them apart and kind of see how that works, and go about finding the area and other information. So anyway, thank you for watching, and we'll do some more examples together in class, and we'll really dive into it there. See you soon.